I guess everyone has experienced this. You're inside a moving car and you observe a person standing on the road. You will see that the person moves backward with the same speed that your car is moving forward. However, you will feel that everything inside the car is perfectly standing still. You throw a ball up, it comes straight down to your hand as if you were on the ground at rest. And to the observer on the road, he will see that the car is moving forward. Let's take another case. Even though the earth is rotating at 1000 miles per hour, but we feel that the earth is perfectly standing still. Let's say you are inside a train and the train is standing still. Now you observe a just approaching train on the next platform. Your mind gets fooled that as if your train is moving forward. So what is the reason behind this various observations, and how can we explain this? So let's find the answer. Today I will be discussing about the pseudo force. Before understanding the term pseudo force, we need to understand what is inertial and non-inertial frame of reference. Now, what do you understand by the term inertial? You might guess that it is derived from the word inertia. Inertia is the tendency of the body to stay in the state of rest or continue with its state of uniform motion. It is actually derived from the Newton's first law of motion, which states that a body tends to remain in the state of rest or uniform motion unless acted upon by some external force. Now, first thing that we are going to discuss is inertial frame of reference. Now, what is frame? Okay, say for example, you are standing on the ground and the ground is in the state of rest. Okay, now, and you observe a car that is moving on this ground. Now, this frame where you are standing is your frame of reference. You are seeing the car and all the physical phenomenon that is occurring inside the car is observed by you from this ground. So this is the frame of reference. We have understood what is a reference frame. Now we should understand what is inertial frame of reference. Inertial frame of reference is a frame of reference from where the Newton's law of motion is valid. First point is that Newton's law of motion holds true. That means F equal to ma holds true from this reference frame. This frame of reference can be on the state of rest or uniform motion. So you can be at this frame of reference. This might be at rest, or you might be moving with some uniform velocity, and you observe another physical object where the Newton's law of motion is valid. After that, we need to understand what is non-inertial frame of reference. Non-inertial frame of reference. What is non-inertial frame of reference? Non-inertial frame of reference is a frame of reference where Newton's law does not hold true. So F equal to ma is not valid. This is not valid from the non-inertial frame of reference. As well as this non-inertial frame of reference is actually acted upon by some external force. So it is in a state of acceleration. Accelerated, ACCLERATED, accelerated state of motion. Motion with respect to the inertial frame of reference. So to understand this idea more clearly, we are going to take an example. So we will take this example where you are standing on this frame of reference and there is a car. Okay, inside the car there is a pendulum that is hanging. Okay, so you are on this ground, this is your frame of reference, and it is on the state of rest. The car is moving forward with some velocity, or you can say with some acceleration. Now you will observe that this pendulum will move backward. So how can you explain this system or this phenomenon using physics? So if you take this pendulum which has moved by some angle theta, okay, so what you can do is, you know that the weight of this pendulum is acting in this downward direction, as well as there is a tension that is developed on this string such that it is always pulling in nature. We know that. Now this tension can be resolved into two components. Okay, this angle is theta, this is the alternate angle theta. So this is the horizontal component, so this is t cos theta, this is t sin theta. So from this simple analysis, you can say that t cos theta is balancing this weight of this bob of the pendulum, and F equal to ma means that, and this force t sin theta is accelerating this bob in this forward direction. That can be understood by using the Newton's law of motion. But now there is another case where, suppose you are inside the car. Instead of being outside the car, your frame of reference has changed. Now you are inside an accelerated frame of reference, that is A, which is the non-inertial frame of reference. See, as I have said that it is in a state of acceleration with respect to the inertial frame of reference. Okay, the ground is the inertial frame of reference and you are in the state of acceleration, and you are observing this pendulum from the non-inertial frame of reference. So to you will feel that as magic, that this pendulum has moved backward. So suddenly you and pendulum are inside the same car, but the pendulum has moved backward, and that comes as a strange phenomenon to you. How can we explain this phenomenon by using the physics? In this situation, pseudo force concept comes into play. So pseudo force, as the name suggests, pseudo, P-S-E-U-D-O. Pseudo means imaginary. Actually, it's not actually existing, but it is introduced in order to make the law of nature valid. So you'll try to resolve again the tension into two components. Say for example, this is the tension force, and this is t sin theta acting in this direction, and this is t cos theta, same as this. But here also the weight of the pendulum is getting balanced by t cos theta. That can be understood, but we cannot say that t sin theta is accelerating this pendulum, because both are accelerating, both the person as well as the pendulum is accelerating in the forward direction. So to him, he will feel that the bob has to be stationary. It should not have moved to the backward direction. So to explain that, we use the pseudo force concept. This is the pseudo force, that is, this is the negative ma that is acting in this backward direction. Okay, such that t sin theta in this case is getting balanced by this pseudo force that we have introduced in the backward direction, such that this pendulum has now become stationary. In this case, the t sin theta was accelerating this bob in the forward direction, but in this case, this mass into acceleration is balancing this t sin theta, such that this bob, as observed by this person, is stationary with respect to his frame of reference. Understood? So what is a pseudo force? Is that pseudo force is an imaginary force that is introduced in order to make this law hold true inside the non-inertial frame of reference. So we can take another case where you are inside a train or a car which is moving forward with an acceleration of a. So you are standing on this surface. To an outside observer, how he can say that the person inside this train is holding on to the surface even though the surface is moving forward? It is obviously due to the friction. The friction is applying a force in the forward direction such that it is trying to move this person in this forward direction with this surface. That is an obvious case. Otherwise, if this was completely smooth, then you can say this will move forward and this will slide and this person will not be able to move forward with this surface. And we can use the simple F equal to ma equation to explain this. You can say that there is a friction force acting at the contact surface such that this friction force is the only external force acting. F equal to ma. This frictional force is equal to ma. This frictional force is causing this body to move forward with an acceleration of a. That is easily understood. But now we change the frame of reference. Now we take an observer that is inside the train himself. Okay, his frame of reference has now been changed to a non-inertial frame of reference. So in that situation, you cannot say that this friction is causing this person to move forward with an acceleration of a. To explain this condition, we need to introduce a pseudo force. A pseudo force such that that is equal to mass into acceleration. This is the pseudo force which is balancing this frictional force. And here also, in this case also, you can see that F equal to ma would be the situation. This frictional force is balancing this pseudo force such that this person is now stationary with respect to the surface and moving along with this surface with an acceleration of a. Thank you for watching this video. Hope you learned many things from this lecture video, and hope to see you soon on other lectures.